Hello. In this lab, involving just play with this online physics simulation applications. And what you just click this one and use this. Okay, just run online. If your computer is fast enough, it's interesting. So it simply simulates something is moving at the same time, show the velocity vector and acceleration vector associated with it. So you just move this along. Okay, you just grab it. Pretend that your hands is the force. The force create acceleration, and so then just move this around. Of course, if your computer is fast, you can simply follow the ball. Hold your right key and move it around, and just play with it. And then, so which. So there are two vectors. I ask you to question. First one I will ask you in the lab is which one is the acceleration and which one is the velocity. Velocity is where and how the object moves, and acceleration is velocity changes. They are definitely not the same, but they are closely tied together. Okay, so which one is it? So see if I go a constant motion and try to do a constant motion, see there's, look, obviously when there's constant motion, the velocity not changing, the blue don't show up. Okay, which means which one is acceleration then? The green one is not acceleration, is the velocity, and then the blue is actually the acceleration. Okay, there's a question. Which one is? The answer is the green one is the velocity. The blue one is acceleration. So if you go and you slow down, the acceleration comes. If you're accelerating, so that's how you can move it. So remember, pretend that your hands or the mouse cursor is the force, and then just move this around. And the second part of the lab, I want you to the automatic simulation. So this is the linear simulation. Click right here. Then, so when you accelerate, you see this acceleration and velocity are in the same direction. There was a linear. Okay, but so the more acceleration, the velocity grow up faster. But when you slow down, the acceleration is in opposite of the velocity. So accelerating, slow down, and then it's like pressing the gas and then press the brake. So the accelerator and the gas pedal and the brake are both cause accelerations, but then the brake will cause the negative, or reduce the speed, and the gas pedal or the accelerator, they actually call it the accelerator, is creating positive acceleration. So you go like this. All right. So this is just to show. And then now you click stop, and then you want to see if you can use your hands to do this. So you can use your hand to do simulate the accelerating. Just get a few. All right. Not much math, but there's a vector. As you imagine, you have to make the software, then you have to really know the application. You have to really know how do you represent the vectors in mathematics. So for those of you who are computer science major, who are taking physics, this really, you understand the physics and to do such an app. So to make such an app. So you see, and also now, and then you click. So then next is curving motion. If we can move a curve, and in this case, the acceleration is no longer in the same direction as, not necessarily in the same direction as velocity. So acceleration, the blue, could be in the same direction. It could be in different directions. So you see, but they point to the direction, and the velocity changes. So see, if we go this, and the blues keep on saying changing that way, changing that way, changing that way, or if you go that way, changing that way, changing that way. So now if you're loading on a circle, see, your hands supposed to be going the other way. So now, so acceleration is in all the words in the direction of total force applied to the object. Pretend that your hands are force. Go that way, and then that way, and then the force. Okay, so now you can stop, and then you do a circular simulation. So that's, the computer does it. So you do a circle, you see that when you do a circle, the velocity changes, but the velocity's magnitude doesn't change. It stayed constant. Look at the green. The same magnitude, but in the opposite, keep on constantly changing the directions. Well, at the same time, the acceleration point to 90-degree perpendicular, which means, okay, I want you to change, but not change the magnitude, but change the directions that way. So therefore, velocity change that way. So then, in fact, the velocity changes constantly. The speed stayed constant. Once again, the speed is just the magnitude of velocity vector. The velocity contains the direction. So in circular motion, the acceleration is toward the center, and the velocity is in a tangential direction. Both of them constantly changing directions. Constantly changing directions. Both are vectors. These vectors are constantly changing. So then you can do that. And of course, if I ask you where the force is when you're doing circular motion, you realize that Newton's second law says the force causes the acceleration. Then therefore, you have to provide a force that in the direction of acceleration you want. Okay, in this case, the force towards the center, or you can say perpendicular to the velocity, 90-degree, or that force that keeps the object going in a circle is called the centripetal force. Okay, remember, the force that keep object moving in a circle is called a centripetal force, or you can say in a radius direction or the radial direction, but it's the opposite to the radial direction, radius direction. So that's this force over here. All right, stop. Now, and then let's look at the last one, and the simple harmonic motion. Okay, that one is a type of motion we would study in later physics class, and it's simply a type of motion that that object in which the object is oscillating, which means the periodic motion, but back and forth. Back and just swing back and forth. A typical phenomena in daily life, you will see that this type of motion is a swing or a pendulum, or the guitar string that's vibrating. It's like, so there's velocity and acceleration, and both the velocity and the acceleration are going in a sinusoidal form, but they are not in phase. Sinusoidal means a sine curve or cosine curve. They're going up and down. In fact, there is a question in physics. If I ask you, when the velocity be zero, can the opposite acceleration be non-zero? Okay, if the velocity is zero, can acceleration be non-zero? And the answer is yes, but that can occur only for a short moment. Okay, usually acceleration and velocity be non-zero for extended period of time. It can, but like in the same time, the circulation and constantly accelerating. But if only acceleration occurs, but that can only occur for a moment. In this case, for a moment, it's like, see, when the object to the end, oscillate to the end, so it's accelerating and then reducing. There you go, at that moment, and acceleration, only acceleration, but it only occur for a moment and not extended amount of time. There, see? Now, there, yeah, at that moment, acceleration, only acceleration, so, but only for a moment. So I'll go to the end. There you go, acceleration, deceleration, acceleration, deceleration, and there. Okay, so that's the typical situation. And then of course you can play around, and there's a few of this screenshot of this, and I want you to match different situation and with actual motion. So that's actually the real physics I want you to learn. But if you are puzzled how to match all those things in the lab, and you just go back to here and try to make that kind of motion by hand. See which one is this. For example, which one is circulating counterclockwise. So you just do a counterclockwise, see what it look like. Okay, and acceleration go that way, and the counter. Which way is clockwise? Once again, always think about your hands as the force or the acceleration direction. See the counterclockwise, or constant motion, and so on. Hope this helps. And if you have questions, you can always make an appointment, and we can talk about it. Bye bye for now.